You can see me? Because it's not just me here. Actually, we have a conference here. Look at that. Say hi to everyone. The team that hosted the 2018 Congress at Brisbane. We've got Susan Fuller here. It's only by accident that the wine is behind her, and Paul Rowe, and yeah, lots of other people. Oh yeah, and also my talk is actually co-authored by Paul, Katie Turlington, and Danny Texera. So it's actually great to have all of us in one room. So let me quickly share my talk. So yeah, I'm gonna talk about automated monitoring of frogs in the Condruk Pericuta forest. So water is always a huge issue in Australia here. And the Murray-Darling Basin is really kind of our answer to the Mississippi or the Danube. It's kind of the defining river of the continent. And unfortunately, big river usually has big problems, right? So the Murray-Darling, for example, has a natural runoff of 24,000 gigaliters a year. Unfortunately, at the moment, half of this is diverted to agriculture. And if you think, what can you grow here? If you've been, well, some of you have been to the last Acoustic Congress, and can point, sorry. Some of you have been to the last Acoustic Congress, and you know that there's actually a lot of kind of, semi-arid places here. But we actually, we're very technically savvy. In Australia, we actually grow rice and cotton in the desert here, and really divert, is no joke, really divert 12,000 gigaliters to do that. And including evapotranspiration, really the full outflow is really reduced by 60%. Obviously, this causes issues for water quality, causes issues for river health and biodiversity. However, about 10 years ago, the then even conservative government pledged water buyback. So they bought a whole bunch of water back for restoration. So in the plan was about 2,000 gigaliters. At the moment, I think they're at about 1,300. But they buy back and they release as water allocations to the environment. Now, the problem is everyone always bickers about whether they work. Some green groups think it's not enough. Farmers just think it's a waste of time. And a very good friend of mine, with whom I'm actually currently leading a large monitoring program, Alison King, wrote in a paper that really it's a lack of long-term monitoring studies for these ecological responses has led some scientists and policymakers to challenge the entire discipline of environmental water allocations. So that really links back to what Jerome just said, right? That we really need this long-term monitoring, and really, especially acoustics is obviously perfect for some of these long-term monitoring programs. So years ago, if you were here in Brisbane at the last Congress in 2018, Joe Woderetic and I presented a study in which we monitored the response to water allocation. So what we did then, we had recorders at 4 sites, and then Joe and her team went to the arduous task and manually counting all frog and bird sounds in these. And what we could demonstrate that for water-dependent taxa, after these water allocations, which are here, here, and here, for water-dependent taxa, usually after a water allocation, the activity went up quite a bit. But these were obviously manual counts. And by manual counts, I really mean Joe and her team listening manually listening to recordings and annotating what's there, which is obviously a lot of work. Now we then chased it through, because at the time acoustic indices were kind of the hottest thing in the universe. Jerome in every talk spruiked how awesome acoustic indices were, and what we found is that after a bit of data messaging, so we removed extreme extreme values of the acoustic indices, extremely noisy, extremely quiet bits. And after that, it kind of worked okay after a lot of data messaging. And yeah, we could basically find some relations with ACI and M, but nothing really with acoustic entropy. So last year, the team around here, Danny and I and Joe were tasked with a automatic recognition grant to develop frog recognizers. So that was done by New South Wales Forestry. It's a state government agency, and basically what they had is they had for two years of recordings at 20 sites in Condrook State Forest, Condrook-Perikuta floodplain. And yeah, basically we had to comb through 180,000 1-minute files across multiple watering events and basically determine whether frog calls increased or not. So the flow of the analysis was that Katie identified about 100, 200 calls per species. I have to say, for me, this was completely new land. I had not built a recognizer before, but thank God, Danny Texera actually had just finished a PhD on building recognizers, so excellent. So together we kind of got through it. But yeah, so Katie identified 100 to 200 calls per species, passed them on to Joe for QAQC. We then picked about 10 to 15 to closely examine and build the recognizers. We had this fantastic annotated data set from the Forestry Corporation that had 800 annotated files, which we then used as training files, and we estimated error rates and optimized the recognizers with that. That Katie analyzed what went wrong and just kind of built the recognizers 50 times until they were reasonably good. So as I said, I think it was a steep learning curve because there was a lot of things that you can tinker with the call recognizers. And we're actually just about to write a paper or to submit a paper on the steep learning curve because, and I hope that I'm proven wrong, a lot of the time, not all of the parameters in recognizers constructions are really discussed or defined or examined because you can tinker with the call source, obviously. So obviously, so this is Crinia signifera. So the pulse frequency can be quite different. The amount of pulses per call can be different. So we'll have to obviously accommodate that in the recognizers. Then obviously parameters while building the recognizers. So we used monitor binary point matching. And so for that, the template amplification can be different. And then obviously the recognizer cutoff. So basically this is output from our monitor. Basically what needs to happen is that the template is this moving window that rolls along this axis. And then once it hits a match, it gives you a score. And this for the green template, basically the score needs to be above the green line. If it's below the green line, it's still a peak, but it's not really triggered as a match. So that threshold for the template amplification obviously needs to be examined as well. So how do we decide on these parameters? I can talk about this for hours because we thought about it for hours, but basically the main thing is we tested it a lot and we tried to create good evaluation metrics based on the reference data set that we had basically had matched positives and negatives and calculated the ratio of true positives to, well, actually the ratio of true positives and true negatives divided by the observations. And then we just did that for all of the different templates, for a bunch of different applications, and then also drew a curve of the cutoff and basically this peak where the cutoff, which was this recognizer cutoff, gives us the best rock, is where we in the end set the cutoff and run our recognizers. That recognizer performance was very good for 3 of the species. It was good for 2 of the species and quite bad for 1 of them. However, 1 of the top 3 had a really good performance in the training data sets. But in the end, there was actually quite a high level of false positives when we ran them. So at the moment, we're in the 2nd year of that. This is Jerome asked for long term. We give you long term. So yeah, so we were currently rebuilding these 2 recognizers with improved training data. Katie is about to submit a paper with looking at some of the false detections that we've had. So was really interesting where recognizers fell down. So for example, for Crinia signifera, sorry, sound doesn't work. I didn't share the sound. Remind me to do that later, Paul. Yeah, anyway, sorry. So Crinia signifera can really sound a lot like crickets. So insects really confused the signifera calls, as did other frogs. Whereas Limnodonastis tasmaniensis, for example, was mainly confused by, also for other frogs, but also weather events like rain, for example. Okay, obviously you wanted to know, is it worth doing this? It was kind of cool to build this stuff. It was really fun. We, experimented with new techniques. But what really the Forestry Corporation wanted to know, does it detect responses to restoration? So as I told you before, previously during these indices, yeah, if you massage the stats well, then there is a significant increase after the watering events. Now during the recognizers, it really works perfectly. So the blue line is pre-watering event, the red line is post-watering event, and you can see that the activity or the detections, but that's also linked to the frog activity, really goes up basically within 5 days. We hit these peaks. It was kind of a cool study, and that was really totally not us devising the study design. It was kind of almost matched watered sites and control sites, and what you could see is that pretty much all the watered sites had immediate increases in detections, whereas the control sites, almost none of them had increases in detections, apart from site Q, which I think from memory had some frogs quite far away that could be faintly detected, and site S, which had water incursion from a sewage or some kind of septic tank on the next on the next property, which also made some frogs really happy. Cool. So yeah, we ran a linear mixed model on this, and obviously, so the watered and control was significant. So all the watered sites had an increase. The control sites didn't have an increase. The time obviously did not have a significant result because there's a mix of treatment and time, but there was obviously an interaction of treatment and time. So time was before and after, and the before and after were significant in the watered, but not in the control. These were pettit tests, that short statistical test that looks for breakpoints, and yeah, all of the pettit tests were all significant for all of the watered ones, but for some of the control ones, I'm not entirely sure. I think we might actually have to set the cutoff a bit lower. And yeah, as I said, the Q and S sites, they actually had water incursions. Okay, to conclude, I mean, it's great. So it's the second time in a different place that we actually found exactly the same, that ecoacoustics is a really good way to continuously monitor responses to environmental restoration in general. I mean, Susan Fuller has done projects on this, but also really also for environmental watering. Recognizers it was interesting because I said, for a while, I was very much in the acoustic index camp, but I mean, the recognizers delivered a really sharp response. That said, obviously, thank God we got a fair bit of money for this, because a lot of work went into building and testing these recognizers, right? It's not just kind of crank C-Wave and get some indices out. The other thing that we found is that recognizers are likely to be equipment specific. So for example, for one of them, we didn't have good reference calls out of our own collections. So we went on the internet, Jodi's Frog ID website, and downloaded a fantastic, wonderful reference call, I'm sure by someone with a Sennheiser mic, and then fed that into our algorithm with our shitty field recorder capsule, and it performed abysmal. Because I mean, obviously the AI thinks it's a different thing, and a lot of computational power was needed. It was basically my home. This was during the pandemic. I couldn't be bothered to transfer 1 terabyte to the supercomputer at Griffith, so I had this old laptop of mine, which is actually super grunty, but it rattled for about 28 days in my basement. So there's a lot of computational power. So yeah, so future questions, I think, is really on the transferability of recognizers. That's something that Danny and I are really interested in. She built a few cockatoo recognizers with wildlife acoustics gear, and then tried to transfer it to audio moths, and that didn't really work well. So I think that's a really big question that we really need to get answered, and especially if we get, as Klaus said before, and as Jerome said, if we get to a global framework of trying to analyze this stuff, cross transferability is big. But also, we did this because we were also, I think other techniques could potentially help. So we just used this binary point matching just because we were experienced with it. And plus, I'm kind of a bit scared of deep learning because I really don't know what it does. Whereas the binary point matching is an algorithm that even a dummy like me fully understands every bit of it and what it does. So it's actually kind of nice to tinker with it. So, but that said, I would really like to play with deep learning and things like that for some of the recognizers. And I think that's it for me.
Great. Thank you, Simon. Thank you so much. Very interesting talk. We have some minutes for questions. So, first question from Lynn Swarkov. She said, "Hi, Simon, super interesting. Why do you think some of the frog started early? Was the watering event timed to coincide with rain?"
It's actually because the water arrived. Sorry, I should have said that. It was just a bit much info in a short time, right, Lynn? It's actually oh, sorry. 1 second. Let me just share my screen again. Thanks, team. So it's actually that some of them were watered at different times. The water arrived at different times. So some of them needed to flow through one wetland. Some of them are actually separately watered. So the watering times are actually not not at the same time, basically. So that's why we, well, okay, there's even more to this. So for the watered sites, we knew exactly the day that the water arrived, right? So we could actually tell you the break point. Well, for the non-watered sites, because they didn't get watered, so we didn't have a time for a watering time, we used the average time between all the watered sites as the control, if that makes sense. Just so we could treat it in the mixed model. Yeah, I hope that answers the question.
Yeah, thank you. I don't know if anyone has another question for Simon. Okay, well, I have a question, Simon. You saw I mean, it was very interesting to see two different approaches. First, you saw some data from the analysis of the soundscape using indices, and then the other approach, no, using the recognizer, which is a species-based analysis. As you said, this requires a lot of work. I understand that the final message is that a lot of work finally made sense, right? To go to such a detail and to try to, even if it's not so quick as using indices, acoustic indices, this provides very interesting and unique information for you.
Yeah, I mean, that was also a bit of a simplified message, right? Because it's, I mean, I'm still a bit on the fence with this, right? So this was about certain frogs. And if you're interested in certain frogs, I think you should just build a recognizer for certain frogs. However, it doesn't give you any other info about anything else, right? So with the first, the manual annotation, I forgot how many species there were. I think something like 46 species in total that were water dependent. So I think ecoacoustics or indices or false color spectrogram, they can obviously capture everything that's going on, including, as Albo said before, geophony, anthrophony. So I think there's a place for all of it, for all of these approaches. It's just, if you're interested in the response of certain animals, then I think the recognizer way is the way to go. But I think I was a bit too harsh in my conclusions. Yeah, more to build a bit of a straw man here, but because I think there is, I mean, for example, the next talk, Paul, which will actually, we won't have to switch, so Paul will speak from here as well, but he'll tell you about all the things that a very long-term observatory can provide you. And for that, you obviously also need different analysis methods than just build recognizers for 6 frogs.
Well, thank you so much, Simon.